3, 2, 1.
Here we go.
All right, guys, a toast to the third Modern Goonies podcast.
All
And
right.
to the universe.
Number 3.
To the universe.
Pick number 3, my lord. Track reference.
All right, hello, guys, and welcome to the third episode of the Modern Goonies podcast. I'm your host, Trevor King Minor, and today on the mic, I got two really special guests. I've got my good friend, Michael Ross.
I'm Michael. What's up?
And I got my really good friend, Mark Thompson.
Hello, everyone.
All right, so we now have several social media accounts opened up. We got an Instagram, we have a Twitter. Still working on the website. We'll have that up not too long, and then we're going to try to get our stuff on Apple Podcast. Everything that we talk about right now is going to be a little bit behind because we went to a bi-weekly podcast because doing it every week kind of gave me a little too much to edit highlights and get it onto social media and let people know about it, build up some hype. So we're going to bi-weekly. So I think this one will air, what is it, like July 22nd? Or is it 12th? What? I think it's the 12th, actually. July 12th.
July 12th. Let's
Yeah.
see.
So mark your calendars, even though by the
Yeah,
time
it's
you're
gonna
hearing
be
this,
far out. Yeah,
it's
so
already up.
I should have mentioned this in the second one, but we hadn't planned that far ahead. So it'll air at about a month from the time that we post it. But just want to tell you guys the reason why today is such a special. We have a special little special guest on the podcast is because Michael and Mark both take extreme interest in the universe, the natural world, things like that. They are very scientific and they know a lot about science. Mark is just kind of a hobby, but Michael actually studies physics, so he knows a lot about how shit actually works. So I guess we're gonna dive right into it. We're just gonna start talking about cool shit. Guys, how have y'all been doing?
Good. You want to know a interesting fact?
What's that?
So at the conference that I was at just a couple of weeks ago, actually, first I should preface this with, do you guys know what Kyrgyzstan is?
The country?
No.
Kyrgyzstan?
Oh,
That's
is
that's
the
Kazakhstan.
wait? Is
No,
that the in a
There's a
nutshell
country
videos?
called Kyrgyzstan also. It's one of the Baltic
The
countries.
in a nutshell people.
I
yeah,
didn't know
the
that.
YouTube.
So earlier I was talking about Dr. Matt Kaplan. He actually collaborates with the Kyrgyzstan people.
Really?
Did you see their neutron star video?
No, not yet.
Okay.
I've seen it up, but I haven't seen it.
Well, he actually helped them out with that, and he's
That's awesome.
mentioned in the very end.
That's badass.
Yeah.
Okay, so before we dive right into all the sciencey shit, how you guys been doing? What you guys been up to lately?
I've been doing sciencey shit.
All right.
And I've just been slaving away at work and complaining about how I have not made it very far in life yet.
Oh yeah. I feel
Hey,
that.
you know what? That's all right
100%.
because you're on the podcast on a Friday night. You don't have to worry about all that shit. So
All right.
So sciencey shit, Michael. What have you been up to?
So I've been traveling around the country presenting research, and I have been working on a research article that's going to be published ideally by the end of summer. So that's in about a month and a half's time. In addition to that, I need to take the GRE, which doesn't sound very sciencey because it's a general subject test. And after that, I'm going to get a nice sciencey letter of recommendation from my research advisor so I can actually get into grad school.
That's really awesome. Yeah, Michael is wicked fucking smart. By the way, he's trying to achieve his master's in physics. Are you also doing physics for your master's? Or
Yes.
Okay, and then after that, he plans on pursuing his PhD. So wicked fucking smart dude we got on the mic today. All right, guys, so let's just jump into it. Let's start talking about science and shit. What is the first topic? What do we want to address, like, right off the bat?
Mark?
And you were really inquisitive a minute ago, so what? I mean, go ahead, fucking start drilling them.
How about I just throw a topic out there and Michael just enlightens us?
Okay, so the thing about this is that Mark knows how to ask really thought-provoking questions, and Michael knows how to respond to it with the actual applications of physics and how the world actually works on, like, an equational level. That's not a word. So
Good
yeah,
enough.
so go ahead, Mark. What?
All right, so Michael is actually already familiar with kind of the inspiration for this line of discussion. But at my job a few days ago, I was talking with my boss and some coworkers about some very difficult to understand subjects in astrophysics, particularly black holes. And I was just wondering if you could kind of explain how we know what we know about black holes and, inform me so that I may be better prepared to explain these things to other people.
Okay. So as you guys probably already know, and as people watching may already know, black holes are regions of space where there's a whole lot of mass concentrated at a singular point, and gravity is so strong there that not even light can escape. La la la, everybody knows that. How we know what we know about black holes and how we know that they exist are from direct observations, like tracking the motions of stars around black holes. Specifically, scientists have tracked the motion of, I want to say, between 8 and 11 stars around the black hole at the center of our galaxy from 1998 to 2012. I may have to get a more exact range on that, but it's right around there. And you can see that the stars all are attracted to a single point in space, and they go around this single point in space because they're orbiting it. Direct observations like that tell of black holes. You can also view radio images and X-ray images of X-ray jets and radio jets spewing from either end of the black hole. You know, like
so
when
that'd
something...
be like a quasar?
Yeah, like sort of.
Okay.
And obviously there's gravitational waves, which we now have the facilities to detect. Like, that's the final nail in the coffin that black holes actually exist. But one of the most important and even more crucial pieces of evidence that black holes exist came from the Event Horizon Telescope. A few weeks ago, the NSF published that the Event Horizon Telescope took pictures, like the first ever pictures of the accretion disk around a black hole. That's undeniable proof that black holes exist.
Right. Yeah, that was very remarkable.
So that's viewing the that's a legit view of the event horizon, right? Or
there's a guy on YouTube that explains it really well, probably much better than I could, but it's a view of the light that is sort of how I was explaining the motion of the stars. The light around the black hole did the same thing. Like, there is some light that didn't escape the event horizon. Okay, just imagine light falling into the black hole. And then just imagine light going at a slightly higher angle, nearly falling into the black hole, but being reflected by the gravity, and instead of going at you, it goes right around it and back at us.
Mm-hmm. And
that's essentially what all of that was. Like, a whole bunch of light reflecting around the black hole right back at our Earth-sized telescope.
It's badass. So
it's really cool.
As far as mathematically, I mean, I know it's a question that almost anyone interested in science has on their mind. What do you think happens inside of a black hole? Is there a white hole on the other side? Is it just like a fucking space garbage disposal? Like nothing can get out of it. Everything in it is just destroyed. So it is, from the standpoint of what we know about science right now, or the math that goes behind black holes, what do you think happens inside?
If I could also kind of extend on that question, I had a very similar question lined up. So I know that as you get closer and closer to a black hole, time slows down, right?
Yeah.
And I believe at the singularity, it stops altogether, right?
If you can reach it, yes.
So let's say you were falling into a black hole. Would you ever actually reach the singularity, or would time basically kind of stop before you got to that point?
We actually discussed something similar to that in my modern physics class. So to address your question first, Trevor, what I personally think is inside of a black hole is just everything that it's swallowed I think all of that is either in there or it's been spewed out as either Hawking radiation or, Hawking radiation. But mathematically, there exists a possibility for white holes, but I know absolutely nothing about those. So I can't comment further on that.
Okay.
Mark, to answer your question, would you reach the singularity? I think your atoms would. But you,
right,
as a person,
I certainly don't mean as a living person, but so
could you?
Despite the fact that time is continually slowing as you get closer to the singularity, you can actually reach there. I guess like time wouldn't stop entirely until you got to the singularity.
Yeah, like I think that at the singularity, you've got a point of infinite density, and I don't know the exact equation for time dilation, but I think when you've got, I think the equation probably has mass as a denominator, and when you've got infinity as a denominator, you've got when you divide anything by infinity, you get 0. 1 divided by infinity, say, becomes 0, and I believe that's the equation, or that's the form of the equation that governs time. And so when mass is infinite, when density is infinite, you've got no time moving. But as you travel into the black hole, time does get slower for you. So you're going to observe things actually happening faster than they are. So like you could see the lifetime of the universe happen the closer you get to the center of the black hole, because time is moving slower for you, but the light outside of the black hole is still moving at the speed of light, so time is passing normally as it falls in.
Okay, so what is like the lifespan of a black hole? Will they basically all be around until the universe ends one way or another? Or because I'm curious, like I know, okay, let's say you're falling into the black hole and you're kind of seeing everything in like super fast motion that's going on outside of there. Obviously, I would imagine you can't see, like, okay, let's say that the black hole has a definite lifespan and it ends by the certain point in time, and they may not even have a lifespan, I don't know, so feel free to correct me. But okay, so let's say that happens. So as you're falling into it, you can't see anything from outside the black hole that would occur after the black hole has evaporated, right?
Yeah,
right.
Move the microphone a little closer to your face. There you go. Getting a lot of echo in there. Go ahead,
Michael.
Yes, that's correct. Because when the black hole evaporates, there's nothing else that falls into it. So even if you can see, like, even if time does slow down for you and light does fall in from the future, light only falls in for the lifetime of the black hole, which is a significant amount of time. Like, I can't give you an exact number. Kurzgesagt actually gives you a pretty good estimate on that, but it's a very long time, and it's longer than anything else will exist.
So black holes, they eventually dissipate. Is that because of Hawking radiation? So
Yes.
If we had enough time, eventually black holes wouldn't even exist, right? They would just like fade out because of all the radiation that they're emitting?
Yes. So just in case you didn't know, Hawking radiation happens when virtual particles are created at the edge of a black hole. And virtual particles are created in pairs. I don't know why they're called virtual particles, but when these particles are created in pairs at the edge of a black hole, one of the pairs falls into the black hole, while the other of the pair goes out. And the black hole loses energy when the second of the pair escapes the black hole.
So, do we know how we discovered Hawking radiation? I mean, obviously it's named after Hawking, so was he the one, or how exactly did we come to the conclusion that black holes do emit radiation?
That I don't know. That was in the mind of Stephen Hawking. Somehow he figured out that black holes emit this Hawking radiation, and I believe there was an observation done or a calculation done that proved that Hawking radiation is actually how black holes, among other things, lose energy.
All right. Well, speaking of Stephen Hawking, I'm reading his final book, which was published posthumously, Brief Answers to the Big Questions. And I guess I can kind of bridge off of the time question as it was related to black holes. If I could segue into like the Big Bang. So this is something that he discusses in the book. I know something that's very difficult for pretty much everybody to wrap their minds around is the idea that the universe could have come into existence out of nothing, one, and then two, that that's actually the beginning and that there is a possibility that there was nothing before that because there is no time in which for anything else to exist. So Stephen Hawking talks about something in that book that I think he was a champion of called the no boundary proposal, which are you familiar with that? So you can kind of correct me as I go wrong.
I would love to hear about this.
Oh, crap. Okay. Well, don't count on me for an accurate explanation, but I'll try to convey it to the best of my ability. So I think basically just the key thing is it's trying to establish that there could actually be a beginning and that it would be nonsensical to ask the question, what happened before the Big Bang, because time was not created until that moment. So if you want to clean up my mess here and kind of, even if you're not familiar with the subject, I'm sure you can offer more informed insight on this.
Well,
perhaps.
Your interpretation, like what you just said, is basically what I tell people who ask me, like, what came before the Big Bang. Like, there is no before because time didn't exist.
We've had that conversation before at the saucer right there by the lake. I was like, well, what's before that? You're like, well, there just wasn't. I'm like,
yeah. Like,
well, I don't like that answer.
Exactly. I was actually going to draw on that conversation and try to paint a picture in everybody's mind. Like, so what I used to think happened, quote unquote, before the Big Bang was, like, if you can imagine the universe as a deflated balloon, so deflated that it takes up like just a small iota of space.
Mm.
The balloon is still here with us in space. It's in something, right?
Yeah.
You follow me?
Okay.
So that analogy is null and void when talking about the universe and the Big Bang, because the universe doesn't have to be inside anything at the very beginning. You know, like they say, what came before the universe? It's not like the universe was inside space, because the space is the universe.
So I've heard that balloon hypothesis or that analogy before, but it was with the expansion of the universe. So a lot of people will ask the question, as I'm sure both of you know, okay, well, if everything is expanding from the Big Bang, right, from like the second it sparked off, and the universe is infinite, it's constantly expanding. Well, what's on the outside? What if I, flew my spaceship out to the very edge and I tried to hop out? What's there? The best example I kind of heard of this was from what is it called? They work for Discovery now. I can't remember. The guy's name is Trey. He does all these videos. Where basically, like, imagine the universe is like this expanding balloon. So the balloon is constantly expanding and it's going outward, but that doesn't mean you can't. So you're confined to the balloon. You can't go outside of it. It's just in space and it's just constantly expanding. So you couldn't go to the edge and then go outside because you're stuck on a balloon that's just constantly like lifting you up. So that was the best. That was the best thing I had heard about that, but it still isn't exactly what I would call satisfying, because it still poses the question. It's like, okay, well, when I'm holding a balloon here, it's expanding into my room, which, okay, so clearly it has to expand into our idea of something. So, I mean, what are your thoughts on that? Because, like I said, it's a decent analogy, but it's still one that doesn't satisfy my curiosity on the subject.
So personally, just like I believe that there's nothing before the Big Bang, I also believe that there's nothing outside of the universe. But if it helps, you can sort of imagine that the universe just expands into a bubble of space, I guess, inside a multiverse, because we don't really have the math to prove that there isn't a multiverse.
So let's jump right onto that fucking train. What do you think about the multiverse, man? This is holy shit.
That was loud.
Nearly bad. This is every science geek's fucking boner that they have is multiverse. So let's hear the mathematics on that.
There are none.
Oh.
Like,
well, that was
the
horribly anticlimactic.
I know, but the problem is the multiverse isn't something that science can test. I do know one of Stephen Hawking's last papers is on the multiverse. I actually have it on my laptop. It's something I've been meaning to read for a while. I just haven't had the chance. Let's see.
Does the idea of the multiverse originate from string theory, or was it around before or independently of string theory? Because obviously, I'm sure we've all heard of string theory. I've made like very simple attempts to somewhat grasp it. I have no understanding of it whatsoever.
So why don't you explain? You understand what string theory is, right?
Slightly.
Okay, can you explain it to us a little bit? Because I actually don't know with a definitive answer what string theory actually is. So
okay, I'd like to take this point in the podcast to say I'm not the end-all be-all on all that is physics, and there are people more knowledgeable than I who have written research papers, who have given videos on YouTube. So if you see something or hear something wrong, take what I say with a grain of salt.
Michael's not God, but Michael knows 100 times more than the layperson. He this is what he studies. This is what he's going to have his doctorate in eventually one day. So while you can take it with a grain of salt, he does know what he's talking about for 90% of it. So,
and also to pat him on the back again, I'd like to point out that he's humble enough to admit when he doesn't fully understand something, at least yet. And I think that's kind of a virtue of science in general. It's okay to not know the answer. Just you don't accept that as a final answer. You're always working to gain an understanding.
Well, thank you both.
Yeah.
So what I understand of string theory is that everything, like from the smallest subatomic particles to, the largest stars, which are made of these subatomic particles, those are actually made of small perturbations in space called strings. I don't know exactly what a string is. Like, a string is essentially like the most basic building block of matter that you can get to. It's smaller than quarks, smaller than gluons, neutrons, protons, atoms. Those all reduce down to strings. And I think different particles are formed based on how the strings vibrate, but the strings are on a scale of 10 to the negative 34 meters, which is like roughly 1 trillion times smaller than the diameter of a proton.
Jesus Christ.
Yeah.
My God.
We can't even comprehend how small a proton is.
So okay, so that's one of the things is that if that's so hard to wrap our minds around, do you know what it is that gives us the impression that strings exist? Because it's called string theory, so it's not 100% like this is definitive, but what gives us that implication or that idea that it all is reduced to this thing that we can barely even wrap our heads around?
I don't actually know. I would like to say that there is math behind it, because if there wasn't, it wouldn't be a very good theory and it wouldn't have survived all this time. Excuse me. But going off the assumption that there is math behind it, I would also assume that it fits a pretty good amount of the physics that we have so far. I think there are two competing schools of thought in physics right now, and it's a problem with reconciling quantum mechanics with string theory, I believe, because there's a particle, or a theoretical particle called the graviton, responsible for gravity, and I don't think there's a graviton in quantum mechanics.
So is there anything you've studied in physics so far that it has an issue reconciling what we know about the world or other theories? Are there any parts that don't exactly line up, or it's like really fucking strange why this happens and we really don't have any idea of what's going on here?
Not yet.
Really?
Not that
So
I
most
can
so
remember.
most of the theories that we come up with actually have a pretty good standing in at least in the terms of what we understand with our math. So physics lines up pretty well with most everything that we come up with scientifically.
Well, most of the things that you're taught in a university are pretty well established by the time they're taught. So I don't think they're going to teach you anything state of the art like, hey, this may or may not be true.
Okay.
You know,
so
instead-
let me go on to that with with quantum mechanics then, right? Because there's a lot of
Okay.
people who have an issue with the way that quantum theory kind of works. For instance, what was his name? Schrodinger. He put a critique of quantum mechanics by coming up with the Schrodinger's cat argument, right? Like it is
Yeah.
not dead or alive; it is both at the same time. It was his critique on superpositions. So what? I mean, clearly that kind of sparks, and I've heard some people when they talk about science and they refute some aspects of science. This is one thing they always seem to go to. It's like, oh, they don't even know what they're talking about. Because like they're saying the Schrodinger's cat thing. Look at this, like it's alive and dead. Like superpositions are bullshit. Well, if we pose this idea, clearly there must be something behind it. So and you took a couple classes or maybe one class on quantum mechanics. So what can you explain as far as that goes?
So before I get into that, earlier you asked about the multiverse, and you asked me where I thought that began. I personally think that began with quantum mechanics.
Okay.
There is a many worlds theory in quantum mechanics where, say you've got the cat, Schrodinger's cat, and you personally have an opportunity to either open the box or close the box. When you open the box, there exists a separate universe in that same point in time where you didn't open the box. And then everything sort of spurs off of that. So imagine you're going down I-30 and you decide to get off at, at one particular stop that doesn't matter. In another universe, you wouldn't get off at that stop. And instead you would continue on until you got off at a different stop, a different exit.
So basically, when you're posed with some kind of choice, it automatically creates a system of universes in which both are technically possible.
Yes, in which both happen, but the only one you observe is the one that you're a part of.
Right. So okay. So there are some particles, for instance. Is it light? I'm not sure, but there are some that, in the sense of observe. I know there's parentheses around that. As far as observing some of these particles, that when you actually go to observe them, they are unobservable, but yet when you're not, they are. I'm not describing this very well, but we've kind of talked about this before. What happens as far as that goes?
So, what I think you're talking about is there are properties of a particle that if you really want to know, you can't know two things at once. Like, for example, position and momentum is a classic example. If you want to physically observe where a particle is in space, you don't have a good grasp on how fast it's moving, to give you an example. And if you do know how fast it's moving, you don't exactly know where it is. That's sort of like, you can see that in electrons. People typically think of electrons as particles that orbit the nucleus of an atom.
Okay.
But really, the electron cloud is just a ring or possibly a three-dimensional sphere around an atom where electrons have the probability of being. And it's probabilistic? Is that the word?
I don't think so.
No, I think that's a word.
Probabilistic?
All right.
Yeah, we can check ourselves.
First thing we researched this time. I should have this in incognito.
I'm pretty sure probabilistic is
See
the
all
word.
the porn I've been watching,
Oh,
guys. All right. What is this? What was probabilistic?
Yeah.
I'm like 99% sure that is a word.
Probabilistic. I probably spelled that. Oh shit! It's a fucking word.
There we go. That's what I thought. So
I like that word.
Proud of myself.
I do too. So the sphere around an atom is just a probabilistic representation of where an electron could be at a given point in time. If you decide to observe said electron, you won't have a good read on its speed, if you decide to observe its speed, you won't have a good read on where it is in that probability sphere.
Okay.
So
I totally understood that.
that's kind of a long way of answering your question, I think.
No, that makes sense because I feel like, at least based on the description you gave me, that's something that's maybe a little bit misconstrued in the mainstream of when people go to explain that, because they explain like this particle that is basically it knows when you're observing it and therefore you can't observe it, but that makes a lot more sense as to, well, okay, I mean, yes, but also no.
Yeah, also, the definition of observing in quantum mechanics is different from a layman's definition.
That's why when I said that earlier, I put parentheses around it because I know there's a difference in the way that they're used.
So just to give you a formal definition, an observation is just the particle interacting with the universe, or a particle interacting with something in the universe in a way that you can measure.
Okay. So here's something that I would like to slightly touch on. So you just used an example of, okay, hey, in science this word means something different. I just want to hit directly on this because you study this shit. I want to hit on the word theory in science. So a lot of people are under the impression that when scientists pose a theory, that it's like you and I sitting around. It's like, well, I theorize that this might be what's going on. So, for instance, a lot of people don't believe the Big Bang or evolution is a thing because they're like, oh, it's just a theory. They use that fucking straw man's argument, like, oh, hey, it's a theory, so it's not a fact. Well, gravity is technically a theory, right? Like, I'm not wrong about
Dude,
that.
I believe
gravity is a theory.
Yeah.
Even heliocentrism is a theory.
Yeah.
Right?
So I want to kind of
so.
I want to touch on that. So Mark and I both understand what the meaning of that is, but just to explain to other people, so in the scientific realm of the word theory, what is it? What is a theory?
So a theory is, I think a theory is one step before something becomes a scientific law. So you've got a hypothesis, something that you can test. After many experiments verifying your hypothesis, it becomes a theory. Something where you've got a very strong understanding of what's going on with the thing you're questioning in your hypothesis, but I don't remember the exact criteria for making something a law. But that's why gravity is a theory and not a law.
Okay, I was about to touch on that. So what exactly? I mean, you said you don't know fully, but what do you think are is the discrepancy from keeping it becoming a law? Because like gravity, from the way we understand the universe, is absolutely a thing. So why is it not technically a law?
From my understanding, it would be from an inability to reconciliate basically string theory and quantum mechanics. Like we have a pretty good understanding of how the universe operates, but we don't have a unified way. Like we don't have a end-all be-all of how the universe operates.
Okay.
And gravity is a really big piece of that.
Go ahead, Mark.
And something I could add to that, last February, might have been February 2017, I don't remember. I went and watched a lecture by Neil deGrasse Tyson in Dallas. And the topic of it was scientific literacy, and he discussed kind of the common misunderstanding of what the word theory means in a scientific context. And he gave an explanation of the difference between a theory and a law. And I wasn't thinking about it, but I should have taken a picture of it or something. He had a slide on it. But if I remember correctly, it was something like a law describes something that happens, and then a theory is like an explanation of why or how it happens. Does that kind of jive with your understanding?
Okay, so here is scientific law versus I fucked that up because I'm buzzed. A scientific law is the description of an observed phenomenon. It doesn't explain why the phenomenon exists or what causes it. The explanation of a phenomenon is called a scientific theory. It is a misconception that theories turn into laws with enough research.
Okay, yeah. So that's basically what Neil deGrasse Tyson was talking about. That was essentially how I remembered it. So yeah, a theory doesn't actually become a law. It's an explanation of kind of how it happens, where the theory is just the law is like, this is observed, it never changes, but it doesn't necessarily account for why it happens that way.
Okay, that actually makes a lot of fucking sense. So it's like we can clearly see, oh, hey, what's up, John? We're in the middle of doing a podcast. John walks in front of the camera. We get one of those per episode, guys, walking in front of a fucking camera.
Everybody gets one?
Everybody gets one. Yeah, but that makes a lot of sense, actually.
Thank you for that. And thank you for looking that up, Trevor.
Thank you, Neil deGrasse Tyson. I'm going to make it a goal.
He's our king.
Every single time I'm on here, I'm going to quote him or mention something he said at least once because I'm a huge fan. And I tend to retain things that he says more than I retain, like, a Stephen Hawking book or something. Neil deGrasse Tyson is really good at bringing things down to kind of a layperson's level where it's a little more comprehensible.
I was actually going to say something about that. Like, people who are pop scientists, and I don't say that in a derogatory term. I mean that, as you said, people who break science down to something that's easily accessible to
it's a good
layperson.
Thing, for sure.
Like, we need more people like that.
We need more science superstars.
Yeah, because with all the science deniers that we have, I just think people having easy access to information that might provoke some thought or might contradict what they're saying, if that information were accessible and understandable to these people, then they could have more well-developed opinions on the things that they're either denying or don't agree with. And maybe it could further entrench them into their beliefs, but at least they're more informed about it.
So I want to kind of jump into something that may be a little controversial, but I think it's something that's important. I think it's something that it's important to touch on.
Okay.
Where do we think the line is? Because I know we all three of us probably have differing opinions on this specific issue, so I'm curious to kind of get your perspectives on it. Where do we think that the lines between science and religion are allowed to merge? Is there a place for it? Is there not a place for it? Because all of us are going under the presumption, and I say presumption, I'm very lightly here, that the Big Bang is a thing, because there's plenty of evidence to prove that it was. But some people would take that as, so they would take the idea that, oh, hey, the Big Bang, the universe arise from nothing, is like scientists are saying there's no God, which I think that's kind of stupid of them to do, because
Fair.
I think the idea, it's like, okay, well, hey, before everyone kind of thought the universe was just eternal. It was just this thing that there was no beginning, there was no end. It was just fucking here. But now we're saying, hey, it's down to one point in history. And all of a sudden there was nothing, and then boom, something happened. And it's like, does that not jive pretty well with your perspective of religion? I think so. As a matter of fact, I think it helps your case more than it does hurt it, if you're going to say that there is a God. But a lot of people will just jump on that and be like, well, absolutely not. Nothing can arise from nothing. And they refute it with hardcore shit, and they just call it a theory, and they don't accept it whatsoever. But where do we think that is there a place for science and religion to merge at all? I want to get Michael, go ahead and give your perspective. I'm curious.
Okay. I definitely believe that there is a place for science and religion to merge. But from a completely scientific standpoint, until there is evidence provided of a God, there is no God. Until there is evidence of anything beyond what we know, that thing doesn't exist unless it's hypothesized. But that doesn't mean that you can't reconcile a God and science. Back before I don't want to say denounced, but back before I stopped being a Christian, I took evolution as in Genesis. I didn't think evolution and Genesis and the Bible were mutually exclusive. The Bible speaks in parables, and if you view Genesis in my way, I thought on the first, second, third, fourth, fifth, like actual days, those weren't days but periods of time where things could potentially evolve.
So I want to actually touch on that. So I haven't read much of the Bible. I'll go ahead and admit that. I know a lot more about the New Testament than I knew about the Old Testament. But I have read a little bit of the Old Testament, and one of the things that I looked for, especially after kind of constructing my scientific viewpoint of the world and not being so religious anymore, was it talks early in kind of about it seems like when God made Adam and Eve in the Bible that there was actually he made it sound like there could potentially be other people in the world, but Adam and Eve were just the chosen people. So when I read that, and like if you read it, there's not a whole lot of context there that actually leaves it pretty open. So it's like you don't even have to deny evolution to also agree with religion. Like just because evolution is a thing does not mean that your religion is completely thrown out the window.
Yeah.
But a lot of people will take it like that. And so like me as like a pretty neutral party going back and reading that, I'm like, well, there's actually kind of room for this to fit in here a little bit. So I don't know why instead of trying to make the two merge, like, hey, look, like it hasn't said anything against my beliefs of how the world came, but instead they just adamantly deny it. Like, no, it's not a fucking thing. Like, God made the world and nothing else, when there's actually room for it. So,
see, I think there is some practical value in trying to reconcile the two, just as far as it relates to trying to convince people who would otherwise eschew science that contradicts a literal interpretation of the Bible. Because I think it's more important to get people to be more open to science, whether we're, kind of regardless of their religious views.
right.
So yeah, I think there is some value maybe from like apologists who try to reconcile the two. I think just really what's important is that they are open to science and, are curious and intellectually honest. But I mean, I think if you wanted to, you could probably interpret any religious text in a way that would be reconcilable with, any sort of science that would contradict a more literal interpretation.
And that's
of
a fair
it.
point, yeah.
So I mean, like, obviously, personally, you guys are very well aware of this. I'm not religious at all, and I'm not a terribly
Mark,
big fan of religion.
You're not religious? What?
Yeah, I'm sorry to drop
Dude.
this. I'm sorry to drop this
We
bombshell.
can't be friends anymore,
on all
man.
my
What
friends.
the fuck, Mark?
But yeah, see, I don't know. This is kind of a question that I'm obsessed with myself. And I mean, I spend probably 4 or 5 hours a day on YouTube, just like listening to other people's thoughts on this.
Right. It's something I'm also very curious. I actually like hearing multiple perspectives on this idea.
And see, you talked earlier about how there used to be a presumption that the universe was eternal. And then I think it was Hubble who discovered, essentially discovered the Big Bang, right? Because
everything was moving apart.
Yeah,
So,
he discovered, I guess, inflation, and then so you can logically, get to the Big Bang from there. But I lost my train of thought.
It was the noise in the background, man.
But
reconciliation of
yeah.
religion and science.
This is a question that you were posed a lot. Like you think
Spend
about
4
a
to
lot.
5 hours a day.
yeah, I mean,
perspectives.
I guess I can just pick up without remembering where I was at. But anyway, I was going to mention Stephen Hawking's book again, because they're obviously one of the probably the biggest question is there a God? Or I guess that's arguably the biggest question. And that's the first big question that's discussed in his book. And in there he talks about how kind of naturalists wanted the universe to be eternal. One, like philosophically, some early philosophers like Aristotle thought that an eternal universe was more perfect than one that had a beginning. But also, I guess there was the idea that if there was a beginning, then that's a place to insert God, and that's a place that's kind of beyond the grasp of science. And so obviously, I would imagine, especially as a scientist, it's difficult to just accept, this is impossible for us to understand.
Right,
It's
the God of the gaps kind of argument when you get down to that point, because it's like we don't understand it, so we immediately attribute it to God. So therefore, because we can't wrap our heads around, at least now in the 21st century, we can't really wrap our heads around what was before. It's automatically attributed to God, which I mean, I get that point. So,
right,
yeah,
and see, I'll just use this as another opportunity to mention Neil deGrasse Tyson, because I just adore the guy.
Shout out.
if he ever watches this, I'd love to talk to you, Neil.
Mark would have a fucking boner that would never end.
I'll come be your butler or something, man. Just give me anything. But there's an interview he did, and I'm not sure if it was with like a religious figure or something, but from the line of questioning, it seemed like it might have been. And you know, he was asking Neil deGrasse Tyson basically, like, is there room for a God in science? And basically he was kind of trying to promote the God of the gaps. And Neil deGrasse Tyson had a quote that was something like, if that's what God is to you, and you're just going to put him wherever, you know, there's currently a gap in scientific understanding, then prepare for that to be undone, because science is always answering these questions. And if that's what he's going to be to you, then God is an ever-receding pocket of scientific ignorance.
Yeah.
But I would say also, though, I think that because it's so difficult for us to grasp the idea that maybe there really was nothing before the Big Bang, I think that's one place that probably, at least for our lifetimes, people will always plug in a God, just because, I guess there's no way to really argue against it. It doesn't really make a whole lot of sense to us, with or without a God, that the universe could come from nothing. So,
right. And you see, I think there's a big difference between plugging. I think where a lot of this kind of discrepancy comes from is the fact that a lot of people will argue for religion as opposed to just the idea of a God in general, because that's one of the things they want to specifically attribute their idea of God to their doctrine that they were born into, rather than just the idea of, is it possible that there is a being outside of our laws of the world that we have right now, that is outside of that realm, that can somehow influence it or maybe started it. I think that is much more plausible than the idea of one specific or multiple specific deities that have done this and constantly interfere and have these specific names and whatnot. I think the idea of the existence of a being that's outside of our laws of the world is much more plausible than being like, well, Jesus Christ is that person. Like, I think one is much more easy to wrap your head around than the other.
Right.
And I don't have any issue with that argument. I'm not the kind of person that thinks if you believe in a religion or a specific God that you're stupid. I think that there's enough mystery in this world for that to be a possibility. But I definitely think those who kind of view God as, at least in the scientific realm, are much more credible than the ones who just view it in, well, this is what this text said from thousands of years ago, and this is what I believe. I attribute much more validity to the first argument than I do the second.
To piggyback off of that, I'm not sure if this has already been mentioned or not. I have a hard time remembering things. Heads up. But if you are going to not believe somebody based on their religious beliefs, say, Mark, I give you something that is a fact, but you don't believe me because, say, I'm an atheist. You know, that's a very closed-minded thing to do. And disregarding somebody's beliefs just because, or disregarding a possible fact just because of the person who said it, just because of their beliefs, like, that not only makes you ignorant, that makes you closed-minded and unwilling to accept what very well might be the truth. Like, if you discovered exactly what this person said on your own volition without having been exposed to, say, it may seem like I'm attacking Christianity, but if a Christian discovered what an atheist said in this scenario by their own volition instead of being exposed to the atheist, there's no reason to denounce what the atheist said if you arrive at the same conclusion in either scenario.
Right.
So I would just like to take this time to say, if you denounce anybody, or if you denounce facts based on somebody's religious belief,
or lack thereof, you were closed-minded.
Please don't take that in any way, or don't be offended by that. Just reevaluate your frame of mind and be more open-minded.
Yeah. So I want to kind of jump subjects here because I don't want to get too much into the whole religion.
Oh, come
Yeah.
on,
debate.
Trevor.
I mean, no, I do.
Like,
I think there's a better time for it. I think there's a time where you and I and maybe maybe
Zach.
somebody like Zach could be on it, because that's three different perspectives. I'm pretty middle of the road with it. I don't denounce one or the other. I'm pretty open minded. You denounce it. Zach is for it. So I think that's a better podcast to have.
Well,
Okay.
I would like to point out though, Zach is one of those people who is absolutely very scientifically literate. He does not, as far as I'm aware, does not reject any scientific conclusion
none whatsoever
that he doesn't like. And he's one of those people where I guess I would call him like a progressive Christian. And there's I think he's a Jesuit priest who I saw interviewed by Neil deGrasse Tyson on Star Talk.
Fourth name drop.
It's 4? I thought it was 3.
I think that's 4.
If I remember correctly, his name is James Martin. And like I said, I think he's a Jesuit priest. And he's another one who, I don't know, I feel like for people like that, it's kind of hard to nail down what they actually believe religiously. But what's most important is they're very open to science. And I think one way in which they kind of connect science to their spirituality is they see science as a way to learn about, understand what they believe to be God's creation. So ultimately, I think I would still disagree with them that there's a reason to put God in there at all, but I don't think they're doing any harm to anybody, and I think they're actually a force for good, because somebody who's very closed-minded to science and very like fundamental religious is probably a little more likely to listen to somebody like I think he's Reverend James Martin, or even Zach, if they know like, ultimately they share my belief in the same God, but and they see that, at least in this person's head, it's possible to reconcile the two.
Yeah. No, yeah, I definitely agree with that.
You were trying to...
I'm sorry to... No.
No. Yeah, we'll.
That's all right.
I'll stay on this forever.
I love talking about religion. It's one of the most interesting topics ever for me. I absolutely love it. But that's probably up for a better time. While we have Michael on, and he knows a lot about, the universe in general, we should probably stick to some of those type subjects. So. All right. What else we got? What else can we throw at Michael?
I know when we were kind of like pre-gaming for this, we thought that the Fermi Paradox might be a good topic to touch on.
All right, let's fucking jump right into that. Okay, so for the people who don't know what the Fermi Paradox is, it is this really cool phenomenon that I am absolutely obsessed with. I fucking love it. So it's the idea that the universe is billions of years old. And so if the universe has been around for this long, then it would be reasonable to assume that, and if they progress at kind of the same level that we do as far as evolution and getting to the point where we have all this fucking technology that we can do all this crazy shit, it would be reasonable to assume that eventually some of these other species out there would
Excuse me.
eventually start to colonize their solar systems or other galaxies, because they would get to a point of technology where they would be able to do so. And also, it's been around for billions of years. That's plenty of time to be able to do that. Well, the problem is that we don't see any of that shit. As far as we know, we're alone. There's no one else out there. So the big question of the Fermi Paradox is, where's everyone at?
Right, like it seems like almost a mathematical certainty that unless life is just rarer than we would expect it to be, that there should be other intelligent life out there, yet we see no signs. And we are looking, and we've been looking for a little while.
Yeah, in the grand scheme of things. So to put in our perspective on how insignificant we are as a species, if you view the world on the cosmic calendar, so 12 years, we are in the last second of December 31st.
And by we, you mean humans, right?
The human species are in the last, the last second, right? Is it second?
It's something like that.
Yeah, I'm going to say second for the sake of this. We are in the last second of December 31st, right before it turns to the New Year. So all that other time has been the universe. So we're pretty new. So it would be reasonable to assume that that the universe being so old, there's plenty of time for other species to develop and get to our point. Yet we don't see them. So it's this big question of where is everyone else at? So there's a couple of answers to the Fermi Paradox that people have come up with. They base this off of, what is it, the Drake equation, where it's basically like, okay, mathematically, if we're like this certain percentage to even become a species, then that also means there's about a couple million other chances for that to happen in the universe.
Yeah.
So, given since the universe is infinite, we're not all that fucking special from the way that we've come up. But we don't see any of that. So some of the answers to it are, one of the main ones is called is it the Great Barrier? Is that what it is? Or
It's the Great
Filter.
Filter, that's it. The Great Filter. So it's this idea that there is this point in the development of a species that either no one can get across, that no one can pretty much get past. So one of the early ones is that in early development of biology, so like mitosis and meiosis is actually something that's pretty like crazy that happened in general. So that might be the Great Barrier, the Great Filter, that we crossed that and we're able to evolve to the point that we are now. But there's also the unsettling idea that we haven't hit the Great Filter yet, which means that there is something that happens within our civilization or in our lifetime that we can't overcome, and no species has been able to overcome it. So every other thing in the universe has died out because they can't get past the Great Filter. So this idea could be every species that has ever been gets to the point of they get to technology that they destroy themselves. Or gamma rays wipe them out, or a meteorite just sets them back a couple thousand years every fucking time it hits, so they can never get to the point of global colonization.
They elect Donald Trump.
And then nuclear war ensues.
He's the Great Filter.
Yeah.
Yeah.
So that's the thing. It's this idea that there's this filter that species can't come across, or they can't get past in order to develop to the point of globalization. So that either means one of two things if we go on this presumption. Either A, we've past it and we are the first in the universe that we can see so far in the observable universe to do this, or we haven't hit it yet and we're on the course for utter annihilation and we will all die and be wiped out before we can accomplish universal colonization. So now that I've kind of gone to that whole thing that you two already know, what are your opinions on the idea of because there's a couple of answers to the Fermi Paradox that people have come up with, like, okay, it's simple, it's just this, but what are your opinions on that in general? Mark, I'll let you go first since Michael gave us an opinion last time.
Okay, well, it's not like I have an expert opinion to present, but for one, I mean, I think the universe is just so incomprehensibly large that, I mean, I would say I certainly think it's all but certain there must be other intelligent life. Well, not just other life, but probably other intelligent life elsewhere in the universe because it's so vast and there's so many chances. So unless it's just incredibly uncommon for chemistry to turn into biology, then I would imagine the universe is probably teeming with life, but it might just be so widespread that,
Right.
communication would not be practical.
Yeah.
Because, I mean, I think there very well could be a neighboring galaxy where a civilization similar to ours exists, and people are sitting around the table having a very similar conversation with no idea that we're over here talking about the same thing.
Right.
I mean, I don't really... I guess I'm not educated on this enough to, give an informed opinion on how likely... Or how common life would be, but I think, it's expected that there are some pretty good candidates for life just in our own solar system, like on some of Saturn's moons.
Europa is the main one, I think, right?
Oh, there's Europa, there's Titan, and then last October I went to a kind of a conversation between Richard Dawkins and Carolyn Porco, who is a planetary scientist, who was, I think she led like the imaging team for the Cassini mission. Which is, the satellite that orbited Saturn and gave us some of our best pictures of it and its moons. And she thinks, and she talked about this at length, that Enceladus is the best candidate for life in our solar system.
Really?
Yes.
I'd always heard Europa. I didn't know about Enceladus.
I mean, I think we have a pretty solid bench of candidates. So
yeah.
So I think that would indicate that at least simple life is probably not that uncommon.
I would venture to say it's simple life, like microorganisms and stuff like that, are actually probably pretty common throughout the universe.
Yeah, like I would think so. So maybe the Great Filter exists there, making the jump from single-celled organisms to multicellular.
Yeah, and that's exactly where people propose if the barrier is before us, that's where we passed it, is when we became complex.
But let's say maybe for every million times, or you could even say every billion times that single-celled life develops, you get multicellular life that evolves, to anything that we might recognize as like a plant or an animal. So even if the odds are really low, there's still so many chances for it. Because the universe is just so incredibly vast. I would still think there's got to be a lot of intelligent life out there.
I would think so, and I think it's reasonable to make that presumption. Now, we say this in the regards of aliens, and when the minute you say that, people might automatically jump to little green men and spaceships visiting us. I don't believe in that shit. I don't believe in all the UFO bullshit. Is there some weird stuff out there? Sure, but I don't think if it's out there that they've visited us. I haven't seen any real evidence of that. And if you take Ancient Aliens as evidence, you can go fuck yourself.
Hey, you can go fuck yourself. It's a good show.
All right, let's do that.
Giorgio Tsoukalos is a pretty charismatic character. I enjoy listening to him.
Is that the aliens guy?
Yeah.
Yeah.
Okay.
He was on the Joe Rogan podcast, actually. I know he is. He's a super chill guy. He's got a degree in sports management.
Really?
That's like what his degree's in, yeah.
Why should I believe anything?
I mean, that's
say?
like me. I've got a degree in business administration, but I'm here trying to keep up with Michael talking about physics.
Well, that doesn't mean you can't show extreme interest in one thing or another.
Right. Yeah, business is fucking horrendously boring.
Yeah, the guy from fucking, he was a political cartoonist, became obsessed, and almost helped solve the Zodiac case. So, I mean, clearly your background doesn't mean all that much.
I guess.
Yeah. Where the fuck were we going with that?
We were commenting on the Fermi Paradox.
Yeah.
Yeah, but like,
and the Great Filter. So basically, it's pretty much Michael's turn.
Oh yeah. It was the idea of aliens. So yeah. Aliens. As far as that goes, that's bullshit. Whatever. But as far as are there other species out there like us, just chilling, doing weird shit, like having a podcast? Yeah, I think there's an extreme possibility for that. I think it's all over the place. But my answer to the Fermi Paradox would probably be similar to Mark's, as far as that it's so crazy vast, and we're kind of in this small little dark pocket of it that we probably just can't see all that's actually going on out there. Because I don't even think we have like a real concept on what other planets outside of our solar system actually look like. Like, we have the Hubble telescope, and we use practices of like when planets pass by stars, we can tell kind of like what their composition is, but we don't actually know what these planets look like.
True, but we can, I don't want to say we can get a pretty good idea, but we can, based on their composition, we can sort of compare that to Earth's composition and have an idea.
But just because we can do that doesn't mean that we would necessarily be able to detect things that are not, or things that are synthetic in the universe. So, I mean, just because we can see, like, the light reflecting off of that planet fucking millions of light years away doesn't mean we would be able to necessarily detect that, hey, that is also, they're fucking colonizing out there.
Yeah.
So, I don't think it's impossible. I just think it's so big and we're so far away from everything else that that would be why we don't see some of the stuff that maybe we would want to see out there as far as intelligent life. And that's the thing that I've stuck to. I don't think we're the first. I don't think we'll be the last. I think there's a lot of intelligent life out there, but that's my answer to the paradox. So what do you think, Michael? There are people yelling in the background, if you can hear that.
So the thing that I'm sticking to is a combination of two factors. One, as we mentioned earlier, the universe is constantly expanding. It's expanding very quickly. The further away you go, the faster it expands. Space further away from you is expanding faster. So I don't disagree with either of you. I think that there is a very high chance that there are some pretty high-level intelligence civilizations out in the universe like us. But I think that, one, they're so far away that anything they try to send out is not going to reach us because the universe, the space between us, is expanding faster than their their object that they sent is traveling.
And just for reference, we've done that with our own space. It's like a gold disc that we've sent out as a representation of humanity. And we sent out this satellite into the universe to kind of, if there's any other thing out there, to let them know, hey, we exist. But, I mean, for that to actually come into contact with anything would take such a fucking crazy amount of time that it almost means nothing.
Well, the problem is, the longer you wait, the less likely it is to come into contact with something. Like you mentioned universal colonization, and I'm just going to tell you why that's not going to happen. And it's because space is expanding faster than we can traverse it. So there are a multitude of galaxies out there that we will never reach, because as time goes on, the expansion of the universe is going to outpace.
They get it. So I'm not saying that necessarily that like we're going to colonize the universe.
Yeah, I know that's not what you meant.
But like in general, at least in like certain solar systems, like I think the idea of colonizing your whole solar system is pretty manageable if technology
definitely
continues on the rate that it is, and even jumping to your next solar system isn't all that crazy if you've been around for millions of years. So imagine us in like a couple thousand. Like that's something that's not necessarily out of the frame of possibility. So I think at least seeing that somewhere would be something that would be reasonable to see. But yeah, as far as just like this crazy multi-galactic like space force, no, I don't think that I don't think that's out there. We haven't seen anything of that, but
okay.
Yeah.
Now, second thing, in addition to the expanding universe, I think if a civilization out there tried to send some sort of signals to all space around it, with the expanding universe and the time it would take those signals to reach us, I don't think those signals would be distinguishable from any sort of noise created by our instruments, or, the signal would get lost in other signals that we get, like radio signals from stars, radio signals from other telescopes, X-ray signals from, say, neutron stars, and gamma signals from binary mergers.
That's actually an answer to the Fermi Paradox. I don't know if you intended for that. Like that's when
I didn't. But
yeah, no, that's actually an answer to one of them. Is that like if there was something trying to communicate with us, there's a high chance we would have no fucking idea because we wouldn't know how to comprehend what it is that they're sending us. Because I mean, we communicate in.
Excuse me.
Because I think the best example of this was you and I. We've seen the movie Arrival. And it's basically like what would happen if an alien species that we had no way to really communicate all of a sudden showed up. Like, how would we even be able to talk to them? And it's actually pretty complex. It's not this simple task. It's incredibly difficult to be able to communicate with these people who are right in front of us. So now imagine they're trying to send out a message from fucking light years away. We would have no fucking idea. We would just be like, it sounds like this is a weird little blip in the radio spectrum. Like, we haven't... It seemed pretty normal to us, but yeah. So that's an answer to the Fermi Paradox as well. Is that everyone's trying to communicate with everyone, but no one knows how to receive the message properly.
Fantastic.
Yeah. So that's a pretty good. That's a good little intellectual thought you had there, man.
Thanks, man. Pat myself on the chest.
All right. So let's take a quick break.
Take my horse to the old town road.
I'm gonna ride till I can't no more. I got the horses in the back. Horse stock is. I need a beat, man.
And you got a tattoo.
Serotonin. And it so suits you.
Oh God, I'm embarrassed and also flattered at the same time. All right, so we took a slight break there.
Is that gonna be there? Is that going to be in the podcast?
I'll probably I'll at least put that in an Instagram video or some shit.
Okay.
All right. So, I'm going to jump right into it. We just ended our little conversation on the Fermi Paradox. So, why don't we jump into something that I know everyone on the planet wants to talk about, and that is time travel.
And
don't say it, Michael. This is a PG podcast.
No, it's not. It's fucking rated. I've been cursing this entire time. Say it, Michael.
And AIDS.
Oh! That was really loud. Okay.
I thought he was going to say titties.
Well, I mean, everybody likes titties, but AIDS. Anyway, time travel.
We have multiple audiences with this podcast.
Yeah, I'm sorry, multiple audiences. You can hate me if you want. This is scientific outreach.
Anyways, so I want to jump into time travel. So it's something that everyone wants to do, whether they'll admit it or not, is someone wants to go back or go forward to a certain point because, I mean, come on, how badass would that be? In the realm of physics and what you understand about time travel, is there a way it can be feasibly possible? Because I know in some aspects of the universe, like, for instance, time travel is actually technically possible because, what is it with, like spacemen in orbit and some shit, if they're going at a certain speed, they're actually technically a little bit, is it younger or older than when they return?
It would be...
They're older.
Older, because the closer you are to a gravitational source, the slower time goes.
Okay, so I guess let's actually touch on that first. So we've had a little bit of a conversation before about time. I made the slight comment that...
Excuse me.
I made the slight comment that time was just a construct because that's something that a lot of people say. But you you immediately disagreed with that, and with that same smile on your face. Why don't you explain time a little bit? Like, what is time as far as we know it, and is it a construct? Is it an actual observable thing that we have in the universe?
Okay. So I guess let me say this for the people in the back. Time is not a human construct. The measurement of time is, but time itself is not. If we never existed, the fact that events would still happen in the universe without us is evidence that time is not a human construct. Like, what are we, 4.5 billion years old? Like, the Earth itself is 4.5 billion years old, but the universe is 14 billion years old. And that in and of itself is enough evidence to say that time has passed without human, what's the word, knowledge of it. So there were 10 billion years where humans never existed, where time still happened because events happened. Events had to happen for us to even be here. And for those events to happen, time had to pass in between one event, like in between those two events. Okay. I mean, that's what time is.
So to touch on that slightly, it's a little bit of a deviation from where I want to take the conversation. But this was something we kind of talked about earlier. So we claim that the Earth, what did you say the Earth is, like 4-point-something billion years old? Like 4.6?
Yeah, like 4.5-ish.
Yeah, so we claim that. But there's a lot of people who would disagree with that idea that the Earth is that old. How do we know, as far as the scientific community is concerned, that things are as ancient as we claim them to be? Because I know, radiocarbon dating is one of the major things that we use, but there's been a lot of critique on that it's not something that is reliable. So, in your opinion, is it reliable? And also, what other aspects do we use to measure time?
Well, in my opinion, which is, that of an undergraduate, one who has attained a bachelor's degree in physics, I do think radiocarbon dating is reliable. And, we do a lot of projections based on half-lives of things. So carbon, a radioactive isotope of carbon, has a given half-life. I don't know exactly what it is, but we use that to figure out how old some things are, like fossils. Some fossils have traces of this carbon isotope in it
and it eventually, like, it degrades over time. Isn't that how we measure it? So it's like, all right, if it starts at this point and it's degraded by this, and then you just do the math, and then that's how you determine.
Exactly.
Okay.
So based on what I know, I believe that the earliest traces of carbon that we have found have been from, the very beginning of Earth. But I could be completely wrong on that because I've never studied, like, the beginnings of the planet. I study neutron stars.
Well, and I know one thing that a lot of young Earth creationists will point to try to argue against an ancient Earth is they'll try to find inconsistencies in dating. For example, they might try to find, like, a modern object that has been dated to 1,000 years ago.
Exactly. Yeah, this is something I was actually going to bring up.
So now I'm not a geologist, but I have a kind of a peripheral understanding of this because it relates to some of my other interests, like mainly in evolution. But so there are different dating methods. I think they're all done in a very similar way, but they don't use the same elements to test for everything. So I think for for most fossils, like they have kind of a general idea of how old they are based on previous finds, and so based on that, they'll determine like which elements to test for. So like there's radiocarbon dating. I think there's like potassium argon dating, rubidium, strontium, and they're all useful on different time scales. So
yes,
you wouldn't,
exactly. Yeah.
so if you've got a fossil that we believe is like a few million years old, then you wouldn't get an accurate result doing a dating method that is optimal for like 5 to 25,000 years old. So that is behind most, if not all, of the so-called inconsistencies that, you know, people try to point out to discredit the dating methods. You know, it's just using a method that is not optimal for the given time period.
Yeah, because that's something else that I read into a little bit when you do the at least the carbon dating, was that I think a certain amount of time has to have passed in order for you to get an accurate reading on it. So I read somewhere that something would have had to have been dead for about 100 years or so, give or take, for it to get an accurate reading on. So if you did something that died just a couple of days ago, you might get something horribly inconsistent because it's not reliable before that period of time. And so I think people use that a lot. It's like, oh, well, look, this thing from fucking 10 years ago was measured as like 1,000 years ago, but they take the example of the thing that you have to allot a certain amount of time to have passed before it's actually accurate, and then they just run with that, and it's like, look, it's inaccurate. So I think there's a little bit of a discrepancy with that, but...
What I think you're talking about is half-life.
Maybe that's it.
The time it takes for half of a portion of a radioactive isotope to
I'm not
decay.
a scientist, so I don't know what I'm talking about.
Well, I mean, that sounds like what you're talking about.
Yeah.
So, you know, maybe after the podcast you could look that up. Maybe if that's what you are talking about, add that to your vocabulary, half-life.
Yeah, we don't do corrections corner. We just act like we know everything.
I think we actually kind of got off topic because originally we were going to go into time travel.
Yeah, so that was one of the things we were talking. So at least in the math that we know and the way that we understand the universe, and I know that there's a little bit of like time dilation, like I said before, from people in orbit or technically a little bit older than what they should be. Is time travel possible, or do you think it can't be?
Based on what I know, I think there is a perfect storm of conditions that have to be satisfied for time travel to even happen. And even by saying that, it's not like time travel in that you're going to travel back 20 years and meet yourself 20 years in the past. It's more like, let's say there was a wormhole that opened up, I don't know,
Einstein-Rosen bridge.
Yeah. An Einstein-Rosen bridge, or a wormhole, opened up, say, 50,000 miles from Earth. And the other end of that wormhole opened up near a black hole. Like, pretty close to a black hole, but not close enough to where you fall into it. So, you're close enough to the black hole to experience time dilation. And assuming that the wormhole doesn't close, you go through it. You stay for, say, 3 hours next to the black hole. Time, you know, you experience time at a slower rate than everybody else does. You travel back, you know, you've traveled, 1,000 years in the future? Just to give you a bullshit example.
Yeah, arbitrary number.
Yeah.
Okay, so you could move forward, theoretically, that way.
Yeah.
But I don't think there's really any way you could move back, right? And certainly not with any accuracy. No, with any precision.
I don't believe there is a way to move back unless...
So the one thing I have seen on this, and it was like an early thing from Neil deGrasse Tyson. I think it was before a lot of people knew who he was. Yeah, I'm named.
Was that
fifth?
5?
Yeah, it's 5 times we dropped Neil deGrasse Tyson. It's
Just
fucking
name this episode the Neil deGrasse Tyson podcast.
That's gonna be the fucking name right there.
Super clickbaity.
There
I
we
was
go.
about to say, like, we
Maybe
get
he'll
views.
notice it on some off chance.
Yeah, fucking astronomical. So it was an early video with him in it, and they were talking about time travel, and I believe he said that it was highly unlikely, but it could actually be. So it's like a series of really hot lasers, all kind of warping in this like weird spiral. And it was actually technically possible to bend time and space. But he said the biggest constraint of doing this was that you could only travel to the point at which you turned it on. So that's as far back as you could possibly go, because you could go through it, but you can never go back beyond the day the machine was switched on. So that was like the biggest like issue with it. You could open up this kind of like hole in time and space, but you can never go past that point.
I feel like we've talked about this like way, like a long time
It
ago.
probably was a long
but
time ago, because like I said, this video is pretty old that I've seen with him, and he explained space-time like in a coffee cup and spinning it. It's pretty old, but yeah. So it was an interesting theory that he kind of proposed, and I don't know how. Just this, but he basically explained that this like fucking crazy amount of heat would be able to do that, would be able to warp time and space around it. But yeah, I don't know. It's been a while since I've seen it, but that's kind of a shitty way to time travel, I guess.
Well, one kind of like modern pop culture example of time travel that people may be familiar with is if they've seen the movie Interstellar, which by the way is my favorite movie.
It's a pretty damn good movie.
It is phenomenal.
Fantastic
You should watch
movie.
it, yeah.
I recommend it. 10 out of 10.
There's a point where they're on a planet near a black hole, which I think is called Gargantua. in the
Yeah.
movie. And they aren't there very long, I think, right? Like half an hour,
Couple-
at the most,
yeah,
maybe
like-
a couple hours.
Something
Yeah.
like that.
But while they're there, you know, to them it feels like time is moving at a normal pace. But for the main character's daughter back home on Earth, she's experiencing like years going by as her father is experiencing minutes going by.
That's sort of what I
exactly.
was saying with the wormhole thing. You know, if you're, well, you can continue, but you know, it's the same parallel right there. Like the closer you are to a very massive object, the slower time is, and you know that's evident in that interstellar scene. And I think they actually say like, what, 3 hours here is 3 years in Earth time or something.
Yeah, I don't remember the
effect.
numbers, but it's
something
something
insane.
like that.
So we'll jump that. So say we find a way to travel back in time, right? We find some kind of mathematical whatever, or some fucking weird loophole in the universe, and we're able to go backwards. So there's something to address, and it's the issue of paradoxes.
Okay.
Which paradoxes are one of my fucking favorite things to talk about. I absolutely love it. I think they're badass.
Okay.
So there's an issue of when you travel back in time and you affect something, are you affecting the timeline in which you came from? Like, are you actually affecting the future when you do shit back in the past? Or are you doing something that creates an alternate timeline?
Kind of like the Schrodinger's cat thing.
Yeah, that deviates from the timeline in which you came from. So if you were to jump back in time and do something to fuck with the timeline, then jump forward in the same timeline, nothing would change. But if you stayed there in that timeline, things would be much different because it's a whole different universe or world or whatever the hell you want to call it. So my favorite thing of this to delve into would be the grandfather paradox, because it's really interesting. So you travel back in time, and your goal is to kill your grandfather. That's the reason you're traveling back. So you go back in time, you find your grandfather, and you kill him. But in doing that, you've created a paradox, because when you go back and you kill your grandfather, that means you say you did it at a point before he met your grandmother. Well, you killed your grandfather, which means he never had your father, which means your father never had you, which means you never existed. And if you never existed, that means you never went back and killed your grandfather.
Yeah.
So therefore, you couldn't have done so in the first place. So it creates this kind of paradigm where people either believe that A, it spawns an alternate reality, and that's what I was talking about a minute ago, this alternate timeline that kind of develops from that interaction, or B, what is it? Something in the universe would stop you from doing so. Like, you go to do it and you're fucking hit by a car or some random chance. Like, something in the universe just stops you from being able to kill your grandfather. And that's kind of like the theory. And then the third one is that it's altogether impossible because of issues of paradoxes like this. Which I kind of want to go into. I'm not going to go into it right now, but I want to go into dark a little bit because of that, because it's so fucking cool the way they deal with paradoxes. But so what are y'all's thoughts on that?
Would you like to go first?
Well, I kind of have a question about something you just said.
Okay.
So when you say when you talk about the possibility of like getting hit by a car to prevent you from killing your grandfather, I don't know. This is just such mind fuckery, so it's difficult to even formulate a question on it. But presumably, we're not assuming some like intelligent agent is like, oh fuck, I better stop him from messing things up.
No,
so
we're not assuming that. We're assuming the universe just naturally corrects itself.
Like
in 11/22/63.
basically, like it had already happened before you even traveled back in time. Like it had already been determined before you traveled back in time that you were gonna get hit by the car.
Or just something like I don't even know that's just one of the theories that have been proposed. I have really no opinion one way or the other, but yeah, that's one of the things that some people say. It's that like, okay, well, there is some kind of guiding hand in the universe or some kind of thing that keeps the universe in check to where if you did go to do something like that, it would just not allow you to. Like, you would hit some kind of barrier, or you would die before it happened, or something would keep you from ever having that interaction in general. So it's kind of like this, like the invisible guiding hand of the universe, right, to take an economic perspective from it.
So can you imagine? It would be really interesting if we actually had the ability to travel back in time, but then we had kind of like a whole bunch of new ethical questions to address on whether we should. Because at that point, I mean, I guess we would have to consider all these paradoxes, and we would have to really ponder, like, if we go back, are we going to fuck everything up? Because if so, then obviously you don't want to. But
that's the thing with that is, if we go back and do fuck things up, things would already be fucked up.
Right. So. And
they're not. Which, because of that sole fact, to answer your question. Sorry for the interruption.
No,
did you want to continue?
No.
Okay.
I'm rambling.
So, because of that sole fact, like, things are going as they are, I either think that A, if time travel were possible, you're not going into the same reality that you came from, or B,
okay,
if time travel were possible, circumstances have changed. Talking about the grandfather paradox, maybe the guy that you kill in your universe is your grandfather, but when you go back in time and try to kill this man, he is actually not. So you can successfully kill this man, but he's not actually the guy that had sex with your grandmother to spawn your mom or dad or whatever. You know, he's not a blood relative of yours anymore.
So, are you saying, like, you mistakenly assumed he was your grandpa, or...
No, I'm saying... either A, you go to a different timeline where this is possible and you're not erased because your grandfather is still very much intact in your universe, or B, I guess this would sort of lead into the almost omnipotent universe that Trevor was talking about earlier, where the universe sort of changes the circumstances, where this man is no longer related to you.
Okay, see, just what I'm thinking with that is, like, you could not exist as you exist without the exact same set of ancestors that you have. So, I feel like if you had a different grandfather, you would be a different you. Like, you would not have the same genes, you know?
You're right. But how... Since this is pure speculation, how would we know that?
So... here's the direction I want to take with this. So
okay.
I want to take. So I've been watching Dark a lot lately, which I recommended on the second podcast heavily, and we've been rewatching it because the second season just came out. But it's a really good show that deals with time travel and paradoxes. The thing I want to address is the idea of eternal recursion. So the idea of that, it was proposed by as kind of like a philosophical idea of Nietzsche. Is that how you pronounce
Friedrich
it?
Nietzsche. Yeah.
Oh,
Yeah, the
yeah.
guy, he was he Russian? Or is that what? I think it was
Polish,
Russian.
I think.
Whatever.
I
He's the
don't know.
guy who pretty much he had a lot of opinions on existentialism, and people often mistake him for being as the guy that created nihilism.
Yeah.
But he
Yeah.
actually kind of warned of nihilism instead. He was like, "Hey, you shouldn't submit to it." But whatever. But he also had a couple ideas of the universe in general. One of them was eternal recursion, where basically everything is connected, and the past is dependent on the future, and the future is dependent on the past. So the beginning is the end, which is also the beginning. So everything, no matter everything is basically on this infinite loop, and no matter what, it will constantly repeat, and everything is dependent on one another in order to happen. So say you do that thing of you going back and you alter some course in history, and it causes, but you doing that, you caused an event that was already going to happen. So for instance, I guess the way I could describe this is you go back to what is it? Something about Hitler. God damn it. Basically, you go back to
Kill baby Hitler or something like that.
Yeah. You go back to kill baby Hitler, and you kill them, you kill the person or whatever, but then they have an adopted son, and that's the person that actually turns out to be Hitler. So in you going back and killing that person, you cause them to adopt a son who became Hitler. So what you did, so the past was dependent on the future. The past was dependent on you going back and doing that. And
there's a Twilight Zone episode with this exact scenario where a time traveler goes back to kill baby Hitler. He kills the child of Hitler's parents, and then they I think adopt a son, and that's who becomes Adolf Hitler.
And there's been papers published on this. There's one story, I think we had to read in like high school or college or something like that about it goes through this whole thing, and it's like this mother might not give birth, and it's like a big complication, and the story leads you to be sympathetic towards her, but then at the very end you figure out she's giving birth to Hitler, and it's like, oh fuck. Like
I remember that.
Yeah. So I mean, there's a lot of questions of that. So I just thought that was a really interesting perspective, especially someone as rational as I would say as Nietzsche was, and some of his ideas that he had, and pretty much founding the modern day existentialism that a lot of us have, who aren't like direct believers in religion or God or whatever you want to call it. To have this idea of eternal recursion, I thought was pretty interesting. That everything is just on this constant loop, and no matter what, we're doomed to repeat it over and over again. I thought that was a pretty neat concept of the universe.
Yeah, I guess that's one way to ensure you don't violate the timeline.
Yeah. Is that everything? So the best way that they describe it is like the Treyarch symbol. Is that no matter what, you constantly intersect, and everything is dependent on one loop to loop into the other. Yeah, it's fucking wild.
Yeah, that's whack. Like the guy on the Eric Andre show who says whack.
Hannibal Buress.
Yeah, him.
Don't boo me. I'm right.
Exactly.
Yeah.
I'm going to have to take a moment to think about that. That's interesting.
Tie your brain into a fucking pretzel, dude.
I feel like I've essentially heard of that before, but I don't think I heard about it like in relation to Nietzsche.
Yeah.
I may be saying his name wrong, by the way.
No, I think that's right. I think that's how you say it, but I don't know. I'm not a language dude. But yeah, it was one of those things because I'd heard of Nietzsche based on solely nihilism. That was pretty much what I had known him on. But then after watching Dark, I kind of looked up the idea. I was like, because I had seen something, I was like, I've seen that symbol before. What the fuck is that? And I looked it up, and yeah, it's this idea of actually, I think they mentioned Nietzsche's name directly in the show, and they're like the idea of eternal recursion. And I'm like, what? I look it up, and yeah, it's like Nietzsche had this whole idea of whatever, and a lot of people think it was proposed as just like an idea to get us to sit here and debate, just like a philosophical thing, like it means nothing. But there were actually like side writings of him writing to people in his family, like hoping it was actually what happens, and actually he wanted to pursue a degree in physics because he wanted to delve further into that theory. So yeah, do you have anything as far as your physics perspective of
so if we're talking about like actual physical time travel, including Nietzsche's recursion thing, I can only give you a very vague response in that time travel is impossible because of like some pear-shaped octopole thing.
You know,
It's
I
like
have been with you this entire podcast until you said that, and I'm like, I have no idea what you're talking about.
Okay, so a dipole. Okay, let's start with a monopole. Okay, I'm gonna give you definitions.
I'm gonna guess it's a single pole.
Sort of. So there's not a magnetic monopole, right? There's a magnetic dipole. Magnets have north and south. So a quadrupole you can think of sort of like a magnet with 4 different types of attractions and repulsions instead of just north and south.
It's like a 4-dimensional magnet instead of a 3-dimensional magnet.
Sort of. An octopole is just like twice that.
Okay.
And an octopole, I don't know what atom it is. I don't know what the thing is, but there is a certain configuration of an octopole that essentially proves that time travel is impossible. And I couldn't tell you what it is. This is more like a pop sci thing than anything, but it's something that I heard and something that I need to read into more. But based on that, this recursion thing is not a thing.
But if everything was dependent on the other to happen, then, I mean...
Then the octopole would be like, no, X, cancel.
Well, I mentioned this during our break, but there was a show either on the Science Channel or the Discovery Channel, I'm thinking Science Channel, where Stephen Hawking hosted a party for time travelers.
Oh,
and,
yeah.
Tragically, nobody showed up to the poor man's time traveler party. So I feel like it's experimentally confirmed there is no time travel, because who in their right minds would not go back and visit Stephen Hawking?
Well, what if they did, just not in this timeline?
Well, then it's of no use to us. I guess. I don't know.
What if we live in the multiverse that time travel is impossible?
See, we very well could. Like, there could be an infinite number of universes in the multiverse, but there could also be like an infinite number of multiverses. We have no way to test that.
Have you ever heard of a? Maybe you know this a little better than I do, but I've seen a couple of things of a false vacuum.
I've heard of it, but I have no idea what a false vacuum is.
Okay, so it's kind of hard to explain, but basically, so it's like imagine a pot of boiling water, and in the bubbles that boil is one of those bubbles is our universe.
Okay.
So now imagine that bubble pops. So our universe is constantly on this on the brink of fading out. So our bubble has popped, but the problem is that our universe is so infinitely large that it might have happened somewhere out in the universe. Our bubble has popped and we're about to fade into non-existence, that we would never see it coming. We have no idea where the fuck it is or if it's even happening at all, but it could be and eventually hit to us, and like all of a sudden just like blink, lights out. Like just everything you know erased into non-existence. So like there's basically multiple universes that just like come up, but yours has like popped, and they don't know if it's like a real thing or not. I'm actually going to look this up because I'm not doing a very good job of explaining this, but this was one of the examples that I had heard.
Well, I mean, I guess if that happens, it's not like we really have anything to worry about, because,
we just fade out.
It'll hit us before we know it, and it's not like we'll be around to lament the fact that we're no longer here, so...
Yeah, could you imagine what it would be like to just not exist? Like, one moment we're here, bam, podcast over, roll credits, fade to black.
Well,
Nobody. No parole.
No parole.
There's like a question and answer session on YouTube from some old convention or something where I think it's a panel of like Richard Dawkins, maybe Lawrence Krauss, Neil deGrasse Tyson or something. Some combination of my favorite scientists. I don't remember who all is there.
I can't find it.
But they get a question from a student, I believe it was a student, and they ask, what do you think happens when you die? Or what do you think it's like when you're dead? Something like that. And they respond with asking, well, what was it like before you were born? Where were you before you were born? Like, you just didn't exist. But you didn't know you didn't exist. Like, there was no you to mourn the fact that you didn't exist yet, you know?
Yeah.
So,
yeah, I go in waves with this whole idea. There are days where I am perfectly content with it. I'm like, actually, that's a beautiful end. And then there's other days I'm like, that is the most horrifying thing that could ever happen.
I think...
like, given the circumstances, let's say in the Christian frame, there is a heaven and a hell.
Oh, God.
Yeah, like, if Christianity is actually correct and nothing else is, I'm going to hell. I find solace in the fact that there very well could be nothing instead of heaven or hell, because I don't want to, I mean, this gets into the religion thing that we're trying to push away from, but I don't want to resign to a God that doesn't respect people for being gay or things like that. You know, I would rather be happy not existing instead of burning in hell for all eternity.
So, I don't want to get into the whole Pascal's wager bullshit, but that was immediately where I was going to go with that. Yeah, no, I don't know. I want to believe that there is something after, but that's my thing. It's just a want to believe that there is. I feel like most likely there's probably nothing. And like I said, I go back and forth with this idea, and it's basically like there's some days where I find peace in that. Like the other day, we had this really badass thing like this party that we went to. I'm not going to say where or when or whatnot, but it was like a really good moment that we had, and like these fireworks were going off, and it was amazing. And I was like, you know what? If that was my end and everything just went to black and that was my last moment, I'd be okay with that. And I was totally content. And I was like, if I had died there, that would have been perfectly fine with me. But then there's other days I'm sitting there thinking about it like, you know, today at work, sitting at my desk, like, if I died here, this would fucking suck if there was nothing after. Like, fuck that. But I think it's only terrifying, at least to me, because I can't wrap my head around it. Because it's this idea of one day I will never, like, be again. I'll never... So, like, it's great because you'll never get to experience pain or anything horrible that this world has to offer, but you'll also never get to experience anything that's good with it either. Right. And that to me,
but you won't be around to mourn the fact that you're not experiencing.
And that is my exact problem with it, is because like that, it makes me really sad and terrified to just imagine never waking up. But at the same time, I will never know, never have no idea. It's like every night you go to sleep, you die technically, because like you dream, sure, but there are moments in between you dreaming and not dreaming that, where were you?
Yeah.
You were nowhere.
Like
you didn't exist, or like you're put out on anesthetic. There was nothing. You were there, and then you woke up in a different place. So that in between is what it's like permanently. And that can be because it's something that's so hard. The idea of absolute nothingness is something that is so implausible to wrap your head around, to the point to where your brain wakes you up if you have a fall in your dream, because it has no fucking idea what happens when you die. Yeah, so it makes it horrifying in a way, but at the same time, it's also incredibly peaceful, and it's just reconciling the two. Because, I mean, there's this thing that Christopher Hitchens said one time, name dropping Christopher Hitchens. He said one time that it puts it in perspective. It's like, okay, so like now imagine you're at a party, and death comes up and taps you on the shoulder and says, it's time to leave. And you're sad and you're upset because you're leaving the party. You're like, man, this sucks. I just want to stay. But you got to go. Well, now imagine the opposite. You're at a party and you're having a good time, and then death walks up and has you on the shoulder and says, you can never leave. So, which is worse? So, I mean, I kind of agree with him on that point. It's like, wow, yeah, no, that would suck. Never being able to just rest and peacefully go. That's awful. But at the same time, never getting to experience joy or what this world actually has to offer is also shitty and kind of terrifying in a way. But I'm curious, Mark, what are your opinions on this?
Okay, for one, I would like to just introduce this topic to discuss on another show, because it's like an entire show's worth in of itself. But this kind of relates to something I mentioned to y'all, antinatalism, and a really interesting podcast that I listened to between Sam Harris and David Benatar, who's a philosopher. I think he's a professor of philosophy in Cape Town, South Africa. But like I said, we could go an entire show talking about that, so maybe just set that aside as an idea for the future. But I guess my thinking on this is actually somewhat influenced, though, by what David Benatar talks about in that podcast. I think, obviously, we're hardwired to want to continue to exist.
Right. We see that in even very basic microorganisms, that you're hardwired to, no matter what, survive. Survival is key.
Right. So I think that's why the idea of not existing is so terrifying. But I think if we could just kind of really try to understand the fact that try to imagine yourself in that state of being under anesthesia, like you mentioned. While you're in that state, you're not aware that you're in that state. And when you wake up, it's like, wow, where did the time go? You know, I was just awake, and now I'm awake again. So, I don't like the thought of dying either, because obviously there are many discoveries that I would love to be around to see. You know, if we ever do colonize, other places in space, I want to see that. If we ever could make contact with extraterrestrials, God, that would be amazing. I would love to be around for that.
Yeah. So you'd say yours is more like FOMO than anything?
Yes.
Fear of missing out. But
again, once I'm gone, I'm not going to be aware that I'm missing out. So, I think it's very kind of contrary to our nature. It's in conflict with our nature, but ultimately I don't think it's anything to be afraid of, because it's like the ultimate peace. I mean, just kind of like we mentioned earlier, try to imagine or remember what it was like before you were born.
Right.
You can't, because you weren't there. It's the same when you're dead.
Or the fact that, who the fuck doesn't love sleep? Sleep is amazing. It's great.
Yeah. Yes, it is.
So it's like you just get to do that forever. That's cool. There's one quote that I love, and it was like, those who are dead are not aware that they're dead. It is painful only for others. The same is true when you're stupid.
You reminded me of a quote from the philosopher Epicurus on death, and I think this is probably like an English paraphrasing of the quote, not the exact quote, and it's only partial. But it's something like, it's discussing whether or not we should be afraid of death. And the quote is something like, when we are here, death is not, and when death is here, we are not. And then there's more at the end of it, but I mean, you basically
they pretty much never cross the two. The two never are at the same time.
Right.
Like me and Batman.
Just like you and Batman, you're right.
Yeah.
Damn it. There's one thing by Socrates that he said about death, and Socrates was one of the first people who likened death to like a dreamless sleep. And he had said, not even the king of where the fuck ever, not even the king of whatever, slept so peacefully as in a dreamless sleep. So it's like you said, it's like the ultimate peace. So I try to find solace in that more than anything. But I'm not going to act like sometimes I don't struggle with it. And because of the very fact that one day I will go to sleep and not wake up, that it doesn't lead to nihilism at some points here and there.
Right. Well, see, actually, I'm glad you touched on nihilism, because in a way, I kind of try to take like an optimistic, nihilistic view, because I feel like ultimately,
Kyrgyzstan.
Yes.
To me, nihilism kind of seems like an obvious truth, because when we're dead, nothing is going to matter to us. It's not really going to matter whether we've lived a life filled with utmost pleasure at every moment or the worst suffering.
Because we all get to the same end point.
Because we're not around to remember, Yeah. But in a way, I think that's I think you can either find despair or hope in that. Because I think in a way it kind of liberates you to take risks and just feel free to pursue your dreams. Because, if you screw up and fail, none of it's really going to matter anyway. So, you may as well go above and beyond to try to enjoy what you got while you've got it. And if it sucks and you fail, then oh well. And if not, then at least you get to enjoy the time while you're here.
I think it makes you value the present moment more than it does anything else. Because in other cultures or in other religions, that's the thing, is that you have the promise of the after. Is that it's okay. It doesn't matter how much this life sucks. You got the after. But if you don't believe in that, like Mark said, there's one or two approaches you can take. While nothing means anything, this fucking sucks, I want to die. Or nothing means anything, this is great. Like, I can do whatever I want. I can live my life to the fullest. Live every day like it's your last. And it's one of those things that sometimes it can kind of get hard to do because you get so caught up in the mundanity of just regular life, going to work or school or whatnot, that you forget, like, everyone's on a clock. And your clock's always ticking, and it stops for nothing.
That's why I choose to sleep every day. Like, after I get off work.
I'll go to sleep when I'm dead. Yeah, but, I mean, I think it teaches you to value what you have here in the present more than anything, because it's... Tomorrow I could walk out that door, and I'm not coming back. And did I live a good life? Did I ask that girl out? Did I hit on that girl at the bar? Did I fucking do this crazy thing or invest my money here or whatever? I think it makes it all that more important because tomorrow is not guaranteed and the after is not guaranteed. The only thing you know for sure is here. So what impact do you make while you're here? I think that means more than anything else. And some people find depression in that, but when I really sit and think about it, I don't. I think it's a good thing. I think it's a good thing to realize that you're limited here and your time is finite, and there's a lot of beauty in temporary things. We value it so much because it is temporary, and we wouldn't if it was infinite. We value every moment we have.
Right.
But yeah. we're hitting our last little 20 minutes, so I want to kind of touch on some conclusions and some things that we wanted to talk about that kind of wraps everything together nicely in a neat little bow. And we want to talk about scientific literacy. That was one of the things. Why it is important to trust isn't even the right word here. Why it's important to recognize scientific fact, and what implications that has on society and knowledge in general, as far as being informed with the way the world works. Michael had a couple points he wanted to address here, and I think Mark maybe wanted to follow that up with some stories or something like that. So why don't we go ahead and address this issue?
Okay. I just want to begin by not beginning. The thing you were talking about earlier, I looked it up. It was called Apology, Socrates. You mentioned Socrates talking about death. That's in something called Apology. So if anybody listening is interested in that, that's what it's called. So now I'll begin. Scientific literacy is important because by being scientifically literate, you concede that you are not the smartest person in the universe, that you know everything, and that there are people that know more than you, and that you're willing to put your trust in their knowledge as opposed to your own, because you understand that your knowledge on some subjects is limited.
And it's not even necessarily like one person's knowledge to the other. I think it's more collective knowledge than anything else.
Yeah, like
which
science,
is also important to note.
Yeah, like science as a whole is a collaboration of peers going through experiment, going through theory, and deciding this theory is correct, this experiment is wrong, this experiment is wrong, this theory is correct. I think I just said that twice, but I meant to reverse it. Scientific literacy is important because it gives you a sort of, litmus test litmus test for what you believe in. Like, if you have no idea what your stance on, or what the evidence is on climate change because you don't understand it, but you have a position on climate change that contradicts the evidence that you're unaware of, you can't compare the two because you don't understand what's conflicting with your beliefs. And so because of that, you're going to fall back on your beliefs because that's the most comfortable thing to do. If you understand science and you understand what's contradicting with what you believe in, I think you're more likely to change what you believe. But, with that comes the ability to admit that you're wrong, which isn't necessarily a trait of scientific literacy, but people who are scientifically literate are able to admit that they're wrong.
So what do you have to say to the people who will listen to that and they'll hear you say climate change, right? And immediately their brains are almost turned off because they're like, oh, this dumb motherfucker believes in climate change, which I know a couple people listening who will say that.
Do you want to mention any names?
Absolutely not. No way. So, I mean, what do you have to say to people who are denying it, or they're saying that people are lying, or they think it's like a conspiracy? Maybe not necessarily just towards climate change, but scientific facts in general that they don't buy into. What comments would you have for people like that?
For people like that, I would say, if you really want to believe that climate change is a conspiracy, then if you want to be scientific about it, you really need to find some evidence that supports that. Otherwise, you're just holding on to a very firm belief that the entire body of climate science is wrong and going against you and pushing some sort of agenda that you don't believe in.
That's true. I agree with that, because that's I've kind of heard that argument. At least here in the U.S., people believe climate change is like this big hoax, and that it's basically just an idea to further the liberal agenda. That's something I hear a lot, because it's like if we give them climate change, then they'll seep in some other idea or something of that regard. But my problem with that argument specifically is that it means that not only would every scientist in the United States have to be lying to you, but also pretty much in the world. And what do people in these other random foreign countries fucking give a shit about American politics? That's my biggest issue I have with it. It's like, it's not just us. It's not just the scientists in the U.S. who are like, climate change is a real pressing issue. It's everywhere. Like, anyone who has a scientific mind is like, this is a problem. We need to address this. But for some reason, people cling to the idea that it's this big national hoax. And I find that hard to believe that globally people would have to keep this under wraps. I just don't think that's plausible.
Well, I think in the U.S., a lot of people who scoff at some of the more, I don't even want to call them controversial, because they're not really controversial anywhere but here, but controversial concepts in science like climate change or evolution or the Big Bang, I think that they're under a misunderstanding that these things are like part of a belief system, that, you know, they're just kind of guesses, that they're no different than like a religion, you know, that they don't actually have anything behind them. But I don't think on any of these issues, it's not like a matter of belief. It's just a matter of understanding. Like, anybody who goes in with an open mind and examines the evidence on something that's as well established as like how humans contribute to climate change, if you go in there honestly and just examine the data, I mean, with climate change, just learn about the greenhouse effect. And I feel like, honestly, that's just about all you need to understand how we can contribute to climate change. Understand how greenhouses work and the fact that our atmosphere functions like a giant greenhouse.
So what would you have to say for the people who they think that it's a thing, but that humans aren't really contributing to it all that much? Like, yeah, no, clearly, like, it's happening, but like, we're not really at fault for it. Like, this just happens in nature. Do you guys have any rebuttals to that?
Well, the climate does change naturally, but it doesn't undergo rapid changes without usually some sort of like cataclysmic event that causes that to happen.
Right.
I'm pretty sure climate scientists can probably come up with very accurate models that would explain to us, this is the temperature change that we would expect to see naturally, given all the variables, without any, human emissions of like greenhouse gases, and then this is what we actually see.
Yeah. So my rebuttal to that would be is that there's a lot of people who seem to have this distrust for science in general. There's like this big distrust that they're just lying to you, or that they don't actually know what they're talking about. They're just coming up with these theories. Why do you think that is? Why do we think that, at least especially here in the South, there's this big distrust for science? Like, what do you think brings that about?
Social media.
Social media?
I think that's one of the things. Generally, people who don't believe in science or don't believe that science weighs more than their own opinion.
You see, I do that same shit all the time. Like, oh, well, like I believe in science, and then I'm like, wait, it's not belief. It's just like
science doesn't give a shit.
I don't believe that 2 and 2 is 4. 2 and 2 is fucking 4.
Right.
That's just how it is.
It's not a faith-based position.
Yeah.
It's an evidence-based worldview.
Exactly. Anyways, continue.
So, people who don't think that science weighs more than their own opinion meet other people who think the same thing, and they talk to each other, they validate each other's beliefs in each other's eyes, while also having the option to cut out people who would contradict that worldview. Say Facebook, you can add friends and you can choose to ignore other people. So I have unfortunately been on the offense on some of these anti-science people, and these anti-science people have tended to, I want to say, congregate on various threads, specifically anti-vaccination threads. That's a very big one right now.
Yeah.
And, you know, as easy as it is, when I present contradictory evidence, you can block me out of your life, and you wouldn't have to view any of the evidence that I present.
Yeah.
And I think that's a pretty heavy factor right there that contributes to this anti-science movement.
Yeah, I agree. I think this also kind of plays into identity politics just a little bit as well, because, for instance, like you were kind of saying with social media, you can choose to follow people who are not only your friends, but people that you like in general that genuinely have the same opinions that you do. And when you do that, Facebook automatically recommends, like, oh, hey, well, you liked the Steven Crowder page. You might also like the Glenn Beck page. And so it will recommend things to you that are similar to based on shit that you've liked or followed or whatnot. So just by default, you can automatically ignore the other viewpoint in general, whether that's politics or science. And then you also surround yourself with people who think the same things that you do, and there's never really any discourse and conversation because of that very fact. Like, you don't like to argue or whatnot. Like, you don't want to be friends with somebody who believes in X, Y, or Z, which I think is a huge issue. What was I? Damn it, motherfucker. Lost my train of thought. Yeah, but I know people that don't follow anyone on social media that differs from their viewpoint on anything. And I think that's a huge problem, because I feel like there's a lot of people out there who aren't willing to challenge their beliefs or defend them, at least in a way. They just have this worldview, and everyone wants to assume that they're right. Everyone is like, I'm smart. Everyone thinks that they're smart. But because of that mindset, no one is ever willing to actually challenge what it is that they believe. It's like, nah, like, I'm right. And if they're challenged, they feel attacked, or they feel like their ego is at risk, when in actuality, it just leads to a better understanding and a loss of ignorance. But a lot of people don't view it like that. I think that's a huge issue, especially when it comes to, at least in the scientific regard, is that people aren't really willing to change their point of view or to listen to somebody. Because I fell into that trap a little bit, because I used to adamantly deny like evolution or science type things, but it wasn't because I looked into it and like I've always been a relatively smart person. It wasn't because I looked into it and I was like, no, I disagree with that. It was because I purposely didn't look into it, because I knew that if I did, it would change my point of view, and I didn't want to be wrong. And I'm willing to admit that now. Then I wouldn't have. I would have been like, no, that's fucking stupid. I don't believe that. Like, I looked into it. No, I didn't.
I remember in high school, I was arguing with you in Mr. Cheney's photography class.
Dude, I remember this shit. I remember, yes.
And I was like trying to force you to watch a video in class explaining the Big Bang, like in a very simple way. And you were just having none of it. And I was unrelenting. And I remember it ended up getting kind of heated. Like, I pushed a little too hard, and I remember you texting me after school. You were like, just fuck off. Like, you're being an ass.
Because you had texted me something else, too. But, yeah, I mean, like, you weren't exactly tactful with it. But at the same time, I mean, now looking back, I get it. Because it's like, wow, I was just being blatantly ignorant, and I had no idea.
Right. But see, going back to the question of why people in America are largely so distrusting of science. I agree with the social media thing. I think echo chambers are a huge problem. People, don't challenge their own points of view. And I think, also we see that being a major thing in politics, obviously. That's a whole other discussion.
Oh, yes, it is.
But I think there are a few deeper underlying reasons. For one, we're just not really built to understand really complex ideas. Like, we're built for survival. We're not built to be, pondering the universe. I think it's pretty amazing that we're able to do that. But I mean, we're advanced primates. We're not that far separated from chimpanzees.
Yeah.
So,
okay, but why is it that some people watching this, the second we start talking about these really complex ideas, that they will scoff at us? What is up with that? Like, the idea that you are educated or you know a lot about a certain subject that might be over other people's heads, that people immediately laugh at, look at these dumbasses talking about.
Okay, so my second point is kind of related to the argument that we had in high school about the Big Bang. So I assume you would probably agree with my assessment that the reason you didn't want to look into ideas like the Big Bang and evolution is because you were determined to maintain your conservative religious viewpoint.
I was determined that I think in my high school mindset, it was like you were just trying to fucking shake my faith and nothing will fucking stray me from that.
Okay, yeah. So essentially, yeah, that's what I was thinking. So, obviously I've kind of, unfortunately in high school, I earned a reputation of being somebody that just liked to beat up on religion, which, for the record, for anybody who might remember me from back then but is listening now, I would say I'm far more tactful, far less militant.
He really is. He's done a lot better.
However, I mean, my opinions haven't really changed that much. I've merely come to be more respectful and polite in delivering them. But I really think that kind of conservative fundamentalist religious views are probably the number one deep-seated reason why people are so distrustful of science, because very important key scientific concepts like evolution, the Big Bang, I wouldn't say climate change so much, but these are ideas which directly conflict with literal interpretations of pretty much every creation story, So if you believe that the Earth was created 6,000 years ago and humans were specially created in their current form, and you believe that's the absolute truth, and you have this whole system built around it to kind of strike fear into you if you dare question that, the threat of hell, then you have a pretty good reason to ignore anything that contradicts that, because I wasn't raised in a very religious house. I was told some religious stories growing up, but really it was something I came into more on my own, where I had this great fear, in middle school, that conflicted with this great curiosity. I had this desire to kind of challenge all these things that I believed about why we're here, but I had this great fear that if I dare do that, then I'm risking eternity in a lake of fire. Yeah. And so like I said, that's a pretty powerful motivation to just get people to tune out anything that's going to contradict their creation story, pretty much.
Yeah.
And I mean, look at where we live in Texas. We're in the Bible Belt. I would imagine statistics would show that the Bible Belt is probably, on average, the least scientifically literate region of the United States. I don't think that's a coincidence. I would even bet that if you looked worldwide, probably, on average, less religious countries have a more scientifically literate population. So I think there's kind of an inverse relationship there. And of course, like we discussed at the beginning, there needn't be this conflict because there are, great intellectuals who are also religious. I don't think there are that many of them, honestly, but or at least not in the United States, not in the environment in which we've grown up. Like, I have not met very many of them, but I know they're out there. So anyway, honestly, I would say that's probably the biggest reason, in my opinion. Kind of the fundamentalist religious views that are hammered into kids, from birth, basically.
Yeah. I mean, I think I would agree with that pretty heavily because, like I said, that was my biggest thing, is that there were all these things that I had curiosities of growing up. I mean, shit, I think I was 10 years old and I asked, okay, well, where did God come from then? I mean, like, just really young, just having all these things, but I was always afraid to really dive into it because of, like you said, the promise of hell if you stray. So yeah, I think that contributes to it greatly. All right, so we've kind of hit our 2-hour mark. So is there anything that we would like to wrap up with? Any final thoughts?
Feel the burn 2020.
All right.
In a non-political statement, definitely watch more Kurzgesagt videos.
We need to link them because I can't even imagine that spelling in my head.
Oh, I never knew how to pronounce it until Michael said it. Yeah, it's Kyrgyzstan in a nutshell. Just type in a nutshell.
Yeah.
They explain science and shit beautifully. They make it to where anyone can understand it.
Watch the videos on neutron stars, which I do research on, and one of my colleagues actually contributed on. His name is Dr. Matt Kaplan. He's a great guy. Met him in person. He's awesome. They also have videos on black holes, heat death of the universe, I think. It's really interesting. And finally, if you're interested in what I do, I study neutron star crust cooling and how properties of the neutron star crust affect how a neutron star cools. Boom.
All right, so that's Michael's plug. Mark, do you have anything to plug right here at the end?
I don't have anything to plug, but in a more serious closing statement, I would encourage people, just keep an open mind, and even if you disagree with all of us, like politically or on religion or anything, don't allow any of our personal opinions on things to influence your views on science, because I mean, you could be a Republican and be a lover of science, you could be a very religious person and embrace science. So I think you owe it to yourself to pursue the truth wherever it leads. And if you're confident enough that your current belief system is correct, then it should be able to sustain, any challenges that come your way. But don't just dismiss things that conflict with your current view. Try to go in with an open mind and really challenge yourself and be intellectually honest and follow the evidence where it leads.
All right, I think that's a pretty good closing statement. I don't really know what else to plug. Look up Nietzsche. Nietzsche's cool, man. The train wreck of that name to spell, I have no idea. But yeah, he's got a lot of interesting views on existentialism, life, nihilism, what the universe means. I recommend looking up some of his theories. They're pretty cool. I've done a little bit of research, but not a whole lot. All right, guys. Well, thank you so much for tuning in to the 3rd episode of the Modern Goonies podcast. Go follow us on all of our social media at Modern Goonies on Instagram, Twitter, Facebook. We don't have a Snapchat. No, it's just no. Yeah, no Snapchat.
Send your dick pics to Modern Goonies.
Send your dick pics to Modern Goonies. Yeah, no. If you guys ever have any topics that you would like discussed, you can email us at moderngoonies@gmail.com.
Hashtag dicks out from Modern Goonies.
Yeah, that's our fucking hashtag now. Yeah. So any questions, comments, or anything, please subscribe to our YouTube channel and everything that we have up. If you guys haven't seen the previous episode, please go watch it. Podcast 2, I think I called it "You're a Piece of Shit, I Don't Like You," because that's one of the things that we said in there. We talk about work life, the music industry, escapism, and the Jon Stewart speech that he gave to Congress about 9/11. It's a really good conversation with Chandler and Dustin. Highly recommend you go and listen to it. I think that's pretty much that's everything for the ending notes. We've now gone to a bi-weekly podcast, so tune in every other week for the things that we have to say. Don't know who's going to be on the next one yet, but I will definitely be posting stuff as we go along. So thank you guys so much for tuning in, and I'll see you next time.
Bye.
We need to have something to do at the end. That's just the end always feels awkward. And then right there it'll end.